tools that help operation managers to see whether the process of production is under control or not. It means that they want to see, they want to check products to see uh, they are being produced according to a standard that has been defined for them or not. So operation manager needs some tools to do this. These tools were defined as a statistical process control. And you remember I introduced you two tools or two diagrams, the X bar diagrams and also R diagrams. The both of them were utilized by operation managers to check the process of production. Each of these diagrams, each of these tools contains some mathematical formula, and as I told you, you need to calculate two important parameters to draw this diagram. These two parameters or these two variables were UCL upper control limit and LCL lower control limit. They should be calculated to determine the allowed area that all of the points or all of the variable that is being measured should be located between these allowed area or between these two border UCL and LCL. So we want to do this exercise to see this process is under control. As you remember, I told you, for example, in one company, 7 times operation manager uh, has done sampling action. It means that in each time or in each hour, operation manager selected 5 items and took them to laboratory and tested them and wrote the results, and you can see the result of the each item in each sampling in this table. The variable is mass here, and the unit of the scale of the weight is a kilogram, as you see. Okay. Okay. So please let me upload the PowerPoint to check again the formula together. You cannot hear me. Do you have my voice? Because some of the Some of guys cannot hear me. I think it's your internet problem because some of the guys can hear me. I don't know what's the problem, but I think it should be from your side because some of the students can hear me very well. You can log into class again. Okay. I think it should be from your computer, not on your internet. Sorry, because as I told you, some of the students can hear me, but unfortunately, some of the students have problem. I don't know what's the source of this problem. It's okay now. Okay. Please let me upload the PowerPoint to check again. Okay. Okay. If you remember, I told you for each bar chart, we need to calculate two parameter or two variable, upper control limit UCL and lower control LCL, as you can see through this slide. X was the mean of the sample mean. X was the or variable that should be tested by operation manager. In this exercise, or X or variable is mass or kilogram. X bar is the mean of the average of the X in each sampling. So in each sampling, X bar should be calculated. When in each sampling X bar is calculated, at the end, the average of all X bar gives you X bar bar. That should be used in this formula. If you see upper control limit and lower control limit include X bar bar, not X bar and not X. X bar bar. The average of give you X bar, produce X bar, and the average of X bar produce X bar bar. So you need at first calculate X bar and after that X bar bar. That is the normal standard deviation. A standard deviation can be defined by a designer or the engineer, and it's the parameter of the statistics science. And also, sigma x is a standard deviation of sampling, and it can be calculated by sigma divided by radical n. Sigma and Z are given to operation manager by designer or engineer or relevant percent in company. Sigma is population standard deviation and n in sample size. Okay. By use of these, we can check uh, okay. So in this exercise, as you see, 7 times sampling has been has been taken place by operation manager. In each sampling, operation manager has selected 5 items. Okay. I want to ask you please off your microphone because it makes noise and pause it in the class, please. Okay. I want to ask you how much is n here? How much is sample size is here? Anybody knows? We discussed about that last week. If anybody wants to speak, please let me know. Make him free his microphone or her microphone. If anybody wants to speak. How much is n or sample size here? No, 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 no. How much is sample size? Sample size is a constant number. Yes, Mr. Ahmed, you are right, but this is X bar. This is X bar for spelling one. I ask I ask you how much is n sample size? Sample size. How much is sample size here? N is a constant. N is constant. N or sample size is constant. Very good. Very good. 5. Why, Mr. Axel? You want to speak, Mr. Axel? Mr. Axel, you can speak if you want. Oh, you don't have me. Okay. Okay, no problem. As Mr. Akmal told the sample size is 5 here. N or sample 5. I'm writing for you. N. Very good. Because in each sampling, 5 items has been selected by operation manager or quality manager. So N or sample size is 5. If you see if you did this formula, and in the last line, and small n is sample size, and it should be used in calculating sigma x standard deviation of the sample. So as you remember, a standard deviation of it is calculated as sigma. The sigma and x can be calculated as sigma divided by radical or root square of n. Sigma divided by root square of n. So we need the n in order to calculate sigma and this x. Okay, everything is clear here. In each sampling, 5 items have been selected, so the n is 5. Now we want to calculate each bar for each sampling. Uh, before continue to solving this exercise, please let me say you something. I have here the speed of internet has decreased around the world. Has decreased. This is the reason behind of this is because of the 1st of the January. As you know, now is the New Year of the Christians, New Year of the in Europe, in many countries in the world, in Europe, in Canada, United States, Australia, and some countries in Asia. So I have here, because of the heavy load in the internet, the speed has decreased. So also in Iran, we have problem too. Yesterday I have a class with Iranian people. The speed of internet was so bad, so that the many students unfortunately couldn't log in the class, and it is the reason that some of the guys send me message and tell me speed is very bad, or we have not we cannot hear you, we have not your voice. This is the reason. I have here, this is a problem, this is a global problem, this is a problem around the world, and the reason is for now we are in the, I should tell you, we have faced to January, and we have to face to celebration, the New Year celebration of the countries in the world. So the load internet is very high, and so the speed of the internet has been increased. I hope it solved the next week, I hope. And so please let me say sorry. Yes, I know some of the guys can hear me very well, and but unfortunately some of them cannot hear. And I'm so sorry about that. And if you know, and if you see, it is not my problem. But I hope this problem solved. Exercise. So in each sampling, we should calculate each part. How we should do it? As you remember, I told you, in order to calculate each part in each sampling, we should sum up the 5 items in each sampling and then divide it by 5. So we should sum up these 5 numbers in each sampling and calculate each part for that special sampling. For example, in sampling 1, we should sum up 12, 12.4, 13, 15, 15.5. Then the result should be divided by 5. It gives you each part. I want to ask you, please do it, all of you, please do it now and give me your result and write me your result in the chat. Please do it now and give me your result for each part in sampling 1. Okay, very good. 13.58 is for sampling 1. For sampling 2, please do it for all sampling and okay, please do it for all sampling. Okay, very good. Please all of you do it to understand how should you use the outcome of this method. Please all of you do it. I want to ask you. Okay, please check together. For sampling 1, X bar is 13.58. For sample 2, X bar is 14.88. For sampling 3, X bar is 13, sampling 4, 14.02, sampling 5, 14.3, sampling 6, 14.52, and sampling 7, 13.22. Now, in order to calculate in X bar, we should put these 7 numbers together and then divide by 7. It gives you X bar. Okay, please do it. Please do it and give me your results, please. Thank you, Mr. Elias. Okay. And Mr. Elias and Mr. Jawad have calculated the X bar is 13.93. Very good, that's right. Okay. Now, X bar has been calculated and we do the first step for drawing X bar chart. Now, in this formula, upper control limit and lower control X bar is clear now because we succeeded to calculate that. Z has been given to you. Now, you should calculate sigma X bar. If you see the formula, sigma X bar. Sigma X bar has formula. Let's write for you. Sigma X bar equal sigma divided by root square of n or sample size. We have sigma here, okay? We have sigma here. Sigma is 1. How much was n? How much was n? If you remember, n was 5, okay? So sigma X bar equal is 1 divided by root square of 5. So sigma equal sigma divided by root of n. Sigma is 1 and n is 5. 1 divided by radical 5 give you sigma X bar. Produce sigma X bar. Yes, sigma is 1. Sigma is given to you. Okay. I'm going to send you the formula. As you uh, as you can see in the chat, sigma x equals 1 divided by radical 5. 1 is sigma. Sigma has been given to you. If you see, okay, yes, it's approximately 0.45. Very good. Very good. We calculated x bar bar, we calculated sigma x bar, we have n. Now we can calculate upper control limit UCL and LCL separately. Okay, please do it now. Please calculate upper control limit and lower control limit. Please calculate UCL and LCL now. That is 3. Okay. Did you calculate UCL and LCL? Very good. Exactly, Mr. Elias. 15.28 is the UCL upper control limit and LCL is 12.58. Yes, very good, Mr. Elias. Now we can draw or diagram or X-bar diagram very easily. The diagram has composed of two axes, horizontal axis and vertical axis. Horizontal axis is sampling, sampling 1, sampling 2, 3, 4, 5, 6, and 7. Yes, very good, Mr. Warren. Okay, no problem, Mr. Rectangle. It's okay. Okay, as I told you, we draw the chart. The chart has composed of two axes, vertical axis and horizontal axis. Horizontal axis shows sampling, the number of sampling. We have we have 7 sampling here. Sampling 1, sampling. Each sampling has one X bar that we calculate. That we just calculate each X bar for each sampling. The vertical axis shows the X bar. Be careful. The vertical axis shows the X bar, as like this example. We have 7 sampling here, so we should write all of them in the horizontal axis with equal distance, with equal unit. For example, 1 by 1, you can draw unit, 1, 2, 3. The distance between units should be equal. 1, 2, 3, 4, 5, 6, 7. Each of them shows you the sampling. Sampling 1, sampling 2, sampling 3, sampling 4, sampling 5, sampling 6, and sampling 7. Vertical vertical axis shows you X bar. For example, sampling 1 has this X bar. So you put a spot or you put a point that shows the sampling X bar for sampling 1. You should but for sampling 2, we calculated X bar for sampling 2. It was the 14.88. You should draw a point or draw a spot, a blue spot, a colored spot that shows you the relation between sampling 2 and its X bar. And also you should do it for sampling 3, sampling 4. So you have 7 spots or points on this diagram. Each point shows relationship between sampling, number of sampling, and its X bar. Then you should draw two straight lines. The straight line is UCL, upper control limit, and lower control limit. These two lines should be straight and cross the vertical axis, because the vertical axis are X bar. For example, the UCL has been calculated as much as 15.28. You should identify amount of 15.28 on vertical axis and then draw a straight line to cut or to cross this point. Then you should identify the amount of 12.58 on vertical axis and X bar axis, and then draw a straight line exactly like this question, this example. The UCL has been drawn as a straight line. LCL has been drawn as a straight line. LCL is 15, UCL is 17. All of the spots shows the number of sample number or sampling number and the X bar. If all of the spots, if all of these point or blue point or color point was between these two limitations, UCL and LCL, we can say that it may be under control, or it may not be under control. But if only one of the spots was out of this area, this allowed area, they must say this process is not under control. So there is a problem somewhere. As a review and as a remembering, if you remember, I told you if all of the spots are located between these two areas, UCL and LCL, we can say the process is under control. We can say either process is under control or not under control. If you remember, we had some special cases that despite of all of the spots or all of the points were located in allowed area, but we told you this is not under control. On the other hand, if one of the spots, only one of the spots, is out of this area, we can say certainly this is not under control. The process is not under control. Yes, please let me upload. Please let me upload the last PowerPoint. Please let me upload. Okay, please let me review it again for you. patterns in diagram that you may face after drawing the diagram. When you draw the diagram, you can face to one of these shapes, one of these patterns. In this pattern here, then we have the normal behavior. The upper line is the upper control limit, and the lower line in this box is the lower control limit. Okay. If you see all of the spots, all of the points located between UCL or upper control limit and lower control limit. This is the normal behavior, so the process is in control. If you face this pattern, you can say that certainly the process is under control. But please have a look others. Here, the one of the spots is out of the allowed limitation. So we can say certainly this is not under control. Process is out of control, because one of the spots is out of the allowed limitation. Here we have trend. All of the spots, all of the points have been located between upper control and lower control, but we have a trend, upper trend, or you cannot see the screen. Everybody can see the diagram clearly. Okay, I don't know what's your problem, but everybody can see. There is, if you face the trend, upper trend or downtrend, the trend, you can say that the process is not controlled. Despite of all of the spots or all of the points have been located between upper control and lower control, but because we have the trend, we have the trend is increasing or decreasing. In the near future, in the very near future, you should be sure that one of the spots will be out of the diagram, because the spots are going up, and in the next, for example, the next or the two next points maybe fall in out of the control, out of the allowed limitation. So if you face the trend, they are separate. The trends can be divided by two parts. Some of trends are up there and some of trends are down. The both of them, if you face the both of them, either up or either down, you should say the process is not under control. If you face a diagram like this, 2 points are very near, 2 or more than 2 points are very near to lower control limit or upper control limit, no difference. Because some of the points are very near to lower control limit, it shows a danger, it shows the risk. It shows that the process is under risk, and it may as soon one of the points is located out of the allowed area or allowed limitation. So if two or some of the points are very near to lower control limit or upper control limit, you can say that the process is not under control or process is out of control. If the number of the the target, you should draw the target. The target in each bar chart is X bar. If you draw the X bar line, when you calculate the X bar is one number. it was a single number. We calculated it if you remember. For example, in our exercise, x bar bar was 13.93. If you draw this line, the number of the points in above of this line and the bottom of this line approximately should be equal. But here the number of the spots in above the target is much more than the number of the spots bottom of the target. So it shows that there is a problem. The pattern should be normal, that we say the process is under control. But it shows a abnormal behavior or abnormal pattern because the number of the spots above and the bottom of the target are not equal. If you face the erratic behavior, for example, some points are very sharply go up and some of them sharply go down like this. This is the erratic behavior. This is not in order, you know. This is disordered behavior. And also, if you see some of the points are very near to upper control limit. 1, 2, 3 points are very near to upper control limit, and so you can say the process is not under control. If you face to some of these patterns, you can say the process is not under control, despite all of the spots have been located between the upper and lower control. In this diagram, as I told you, you can certainly say that the process is not under control because one of the spots has been located out of the limitation. Just this diagram is normal behavior and process is under control. So if you face such this normal behavior, you can say certainly and without any doubt, and thusly the process is under control. Okay? Okay. It was our diagram for each bar. Now we should do the R bar chart, the R chart. Please, before starting the R chart, I want to ask you, please have a 2 or 3 minute break, and then we can come and continue because I don't like to teach you continuously because I'm worried to be you confused about the diagram. The X bar chart has finished, and we are going to do the R chart. So I want to suggest you have a 2 or 3 minute break and rest your brain. And after that, we can start the R chart. Okay, after 2 or 3 minutes. You can close your eyes and focus and have a deep breath to give your brain rest, give your mind rest in order to increase your performance for our chart. Okay, are you ready? Okay, you want to continue? If you want to continue, we can continue without any break. Okay, okay. Our chart. Okay, our chart. Indeed, let's review the concept of R chart. The type of variables control chart shows the sample range over time, difference between the smallest and largest value in each sampling, monitors process variability independent from process mean. In R chart, we don't calculate mean or average. We should calculate range in each sampling. I'm writing for you the concept of range in the chat. Okay. As I wrote to you for your chat, and as you can see in the chat, R or range is maximum minus minimum in each sampling. So in each sampling, we should calculate. Well, of course, we don't need calculate. We should find maximum number and minimum number and then minus them. So after calculating R or range in each sampling, we must calculate R bar or average of range. Average of range is the sum of we should sum up the R for all samplings and divided it by 7 because we have 7 range in all exercise. Okay. As you see, we left a place in order for calculation of range or R. So in sampling 1, how much is the maximum value in sampling 1? Please tell me. Very good. Yes. Range in sampling 1 is 3.5 because the maximum number is 15.5 and the minimum number or minimum value in sampling 1 is 12. 15.5 minus 12 give you range. Okay. After calculating range for each of the sampling, we must calculate R bar or average of range. R bar is the sum of these seven numbers, seven range, and divided by seven. Okay, will you calculate your R bar or average of range? Okay, very good. Range is 50.3 R bar. Okay. Calculating in R chart is by far easier than X bar chart. So if you see the upper control limit for R chart can be calculated as D and it for the R bar multiply R bar, and lower control limit is D3 R bar. R is the average of the sample. We just calculate. D3 and D4 are called control chart factors. They should be extracted from a standard table with regard to sample size. Or sample size is 5 here, okay? Or sample size or n is 5. With regard to this 5 or this sample size, you should refer to this chart. This is the control chart factor. It is a standard and exists in all of the company. Sample size is 5. Okay, D4 and D3. How much is D4 and D3? Okay. When sample size or n is 5, D4 is 2.115, 2.115, and D3 is 0. Okay? Is it clear, huh? Okay. No, no, no. Directly from table. We will have a look at the table. How much was sample size? Very good, 5. The n is 5. We will look at the left column sample size n and find the 5 in the column of the sample size. N is 5, okay? Okay. And go straight and you can find the D4 and D3. Okay, okay. Okay, R bar is 3.3. Okay, D4 is 2.115. D3 equals 0. So the UCL and LCL can be calculated easily. Please have a look to formula again. UCL. UCL is D4 multiply R bar. So 2.115 multiply 3.3. How much is that? Did you calculate the UCL? How much is UCL? Very good. Yes, very good. 3.9. So UCL for how much is LCL? Very easy. Very, very easy. 0. Very good, Mr. Bharat. because D3 is 0. If that is everybody, I explain again. D4 and D3 are control chart factors that should be found from table. This table that you can see. They should be found by given sample size or n. Sample size is 5 here, and when you look at the table from sample size equals 5, you can find D4 and D3. D4 is 2.115 and D3 is 0. So by using this formula, if you replace the numbers by these parameters, you can calculate upper control limit. D4 was 2.115, multiply R bar. R bar was 3.3. So you can calculate upper control limit, and LCL is 0 because the D3 was 0 from here. Now you want to draw the diagram. The diagram, the same as each bar chart, has composed of two axes. The vertical axis shows you R range for each sampling, and horizontal axis gives you sampling. For example, you should draw the sampling by a same distance or by same unit in horizontal axis, sampling 1, sampling 2, sampling 3, 4, 5, 7, like this. If you see, the sample number has been mentioned in the horizontal axis 1, 2, 3. In this exercise, the number of sampling was 12, but in all exercise that we are doing now, our sampling number is 7. Vertical axis is range. Every sampling has its own range and give you 1 point. R and sampling 1. Sampling 1 has R equal to 3.5. Sampling 2 has R equal 3.8. You can draw the points on this diagram very easily. In sampling 1, find the 3.5 and draw a point, draw a blue point or a colored point that shows you sampling 1 has the R equals 3.5, and do it the same for all of the sampling, and then draw the CA and UCL. UCL is a two straight line that should be cross the vertical axis. LCL is 0. That is LCL is 0. That is the same horizontal axis. It can be 0 on the horizontal axis so the LCL is coincided on horizontal axis because the LCL is 0. It shows the same horizontal axis. And the UCL shows the 6.9. You should find the 6.9 on the vertical axis and draw a straight line. The allowed limitation or limitation, area limitation can be determined by this. If all of the points that you draw, all of the points include the range and number of sampling, were located into in this allowed area, you should check the patterns that I just mentioned to see do you have to see that you have faced to one of these pattern or not. If it was a normal pattern, you can see the process is under control. But if one of the points was located out of this limitation, you can certainly and you should be sure that this process is not under control and there is a problem, and you should check the problem to see what is the source of problem. As I told you, the source of problem can be, for example, the machine can be labor, and it can be something like this. So the operation manager should stop the process control, the process of the production, and try to find the problems, resolve it. It shouldn't, they shouldn't proceed, because if they go further in production, it will be a cost for them, because all of the production come out as effective. Okay. I think all of you should get this topic, because I try to explain you in detail everything, and by solving this exercise, I think you have understand the topic very better. Of course, I hope. So they can do the more exercise for yourself at your home, and if you see there is a problem, don't hesitate. You can send to me email and ask question about the various things that or uncertainty that exist in your calculation or something like this. And by doing the more exercise, if you see, you can understand better the lessons, and there is no problem. All the charts, each chart and R chart are the same, and the method of the working chart are the same in all of the company, the production company. So if you want to yes, I think you have vacation before the new year. I don't know. I don't know how much is that. Sorry, I don't know how long is that. I think it should be between 1 week or 2 weeks, I think. Okay, very good. Okay, I think the next week, okay. I think the next week it should be the last week, okay? Or today was last week. You know, today was last week, or next week is last week for this semester. Yes, I think the next week is the last week, I think. Or you have already completed some subject, huh? I don't know, I should ask the other mean today was the last week or the next week is the last week. If today is the last week, okay, I should give some questions for your exam to academy. The exam is multiple choice, okay? The exam will be multiple choice, and you can check the correct answer easily and without any problem. I don't know. The academy will inform you. I don't know. The academy will inform you, but don't worry about it. Um, as your project or as your assignment, I want to um, write three questions. One question is for forecasting. Second is for the decision-making tools, if you remember, and the third question is related to uh, statistical process control. You can answer these three questions, and you can form a group together and send me the answer. The deadline will be, for example, 1 week or 2 weeks after your date of exam. I want to give you the group assignment. You can share the uh, share the questions together, because the assignment is three question only and it's very easy. You can form a three-person groups. For example, in each group, 3 person. Each person can do one assignment, one question, and you can check together and share together. The question will be easy and is the same as the question that we practice together in the class. No, assignment is different with exam. For example, your exam will be 15 score out of 20 score, and your assignment is 5 score. Your score is out of, I think, 20, huh? 20 or 100, because your score is measured from 20, 15 out of 20 is your exam, and 5 out of 20 is your assignment. Yes, 20 for class participation. Okay, our class has finished here, and if you have any question, I'm at your service. Other than, I wish the best for you, and I hope have a nice time with your family, have a nice night, and I think we should wait for the academy to see, and the next week is the last week, or today was last week. If the next week is the last week, I can prepare a new subject, such as supply chain management and something like this, and we can discuss about this topic next week. You're welcome, Mr. Ayman. I just did my duty. It was my duty, and it was my honor to have such a nice students, and to be familiarized with such a nice guy with such as you. Okay, the exam date will be determined by academic, not me. The academic told me we should determine the date of exam, and they will inform you. They will inform you uh, as soon as possible. I think this week they should inform you. Okay, everybody have a nice time and have a nice night with your family, and I hope have a successful day tomorrow. If you have any question, don't hesitate. Please send to me email, and I have your service. I wish you be good luck in your life, in your education, and I'd like to see you as a top operation manager in future, in near future, in your company, because I'm sure that all of you have a high potential, and I promise you your country will advance very soon with your hard working. No, believe me, I'm telling you truth. It is a truth. It is a fact that all of you have a good potential to be a good manager and work very hard for your country and contribute to advance of your country. Sorry. Okay, there is no problem. Have a nice time, and wish the best for all of you, my nice friends. Have a nice time, and goodbye, everybody.